A team I helped had a scheduled research agent that scanned vendor advisories every 15 minutes. It looked clean: store last run ad, query everything newer, summarize, post to Slack. Then a vendor index lagged by 8 minutes. The advisory was created at 10:02, but did not appear in search until 10:11. The 10:15 run started from 10:15 because the previous run had already advanced the timestamp. One critical item vanished between runs. Their fix was not a faster cron, it was exactly one's processing, built around watermarks, replay, and receipts. Naive scheduled loops fail in two opposite ways. If you query from the last runtime, you can miss items that were written earlier but indexed after your query ran. That is common in search APIs, mailboxes, issue trackers, and vendor feeds. If you query with a broad time range, you process duplicates and spam downstream systems. Then someone dedupes on title, subject, or URL, and gets burned by edits, redirects, translations, or two different records with the same headline. The third bug is partial progress. The agent handles half the batch, crashes, and the stored timestamp says the whole interval is done. That is how reliable-looking automations silently lose work. The pattern is a watermark plus a replay window plus a durable receipt ledger. The watermark is not last run app. It means coverage is complete through this time. Each run starts at watermark minus the replay window, on purpose. The overlap catches late indexed items and gives crashed work another chance. Reprocessing is safe because every candidate is checked against a receipt ledger, keyed by a stable source identifier: Gmail message ID, GitHub event ID, vendor advisory ID, or a version-aware key like vendor X:CVE:revision. My opinion, if the source does not give stable IDs, treat that integration as less trustworthy, and design a human review path. Mechanically, the scheduled loop reads state, watermark, and replay window. It computes coverage start as watermark minus replay window, and coverage end as the current time or an upper bound supplied by the source. It queries candidates in that closed interval. For each candidate, it builds a receipt key from the stable source ID, including revision, when the content can change. If there is a completed receipt, skip it. If there is a retryable receipt, and next retry after is still in the future, skip it. Otherwise, process the item and write one of three states: completed, retryable, or dead letter. Only when all candidates are resolved, save receipts, and advance the watermark to coverage end. Imagine a security research loop that checks a vendor feed every hour and creates internal tickets for new advisories. State says watermark is 0900 and replay_window is 15 minutes. At 1000, the agent queries from 0845 through 1000. It finds advisories A, B, and C. A was already completed yesterday, so the receipt ledger skips it. B is new, so the agent creates a ticket and stores completed with key vendor X:CVE 2026-1234:revision 1. C fails because the vendor page returns a transient error, so the receipt becomes retryable with next retry after at 1020. Because every candidate is resolved into a durable receipt state, the watermark can advance to 1000. This is not magic. A replay window that is smaller than the source indexing delay can still miss work, so measure lag and set the window with margin. Bad stable IDs create false duplicates or repeated processing. If the receipt ledger is in memory, you have built theater, not reliability. Downstream side effects need their own idempotency keys when possible. Creating tickets, sending email, and charging money are not undone by a receipt in your scheduler. Also, dead letter is not a trash can. It means the item is preserved, visible, and needs human review or a new handler. Exactly once here is a practical contract around effects. This sits in the hardening tier because scheduled loops are where small state mistakes compound for months. It connects to stop conditions because each run needs a bounded interval and a clear definition of done. It connects to verification because a receipt should record what was verified, not just that the model said it finished. It connects to budgets because replay windows increase candidate volume. You may need page limits, per run caps, and carryover state. And it connects to orchestration because multiple workers need leases or partitioning, or they will race each other while believing the ledger protects everything. Pick one automation you already run on a schedule: inbox triage, issue scanning, feed monitoring, report generation, anything. In 10 minutes, write down 4 things. First, what is the stable source ID, and does revision belong in the key? Second, what is the real indexing or availability lag you have observed? Use that to set replay window. Third, define the receipt fields: key, state, next retry after, human review required, and timestamps. Fourth, identify the exact line where your code advances last run at. Move that update to the end, after durable receipts exist for every candidate. If you cannot do that transactionally, write down the crash behavior explicitly. Recap. First, last run at is not enough because a timestamp can skip items that were indexed after your query ran. Use a watermark plus a replay window, and accept overlap as a feature. Second, dedupe with a receipt ledger keyed by stable source IDs, never titles, and model item outcomes as completed, retryable, or dead letter. Third, advance the watermark only after the whole batch has durable receipts. If the process crashes mid-batch, the old watermark makes the next run replay the interval, so nothing is lost. New Loop Engineering episode daily on this channel. Practical patterns for agents that finish, verify, and stop.